Good evening, students. Hello. Yeah. No, madam. Actually, this pen is not this. No, no. I opened that first slide. No, madam. From first time, madam. One minute, madam. Yeah, it is coming from beginning, no, madam. I'm not seeing the pen and that. Yeah, yeah. Good evening, students. So from today onwards, we are going to starting with the first few topics. So let us discuss the very first chapter, that is motion in a straight line. So we are going to discuss the concept of the motion in a straight line. Yeah. Suppose if I considered a particle here, this particle is having a mass m. Now, when this particle is changing its position from one point to another point, when the particle changes its position from one point to another point, then the particle is said to be in motion. So when the particle is said to be in motion, the particle is said to be in motion if the body gets displaced from one point to another point. Suppose if it is not changing its position with respect to time, if there is no change in the position with respect to time, then the body is said to be at rest. So when the body is said to be at rest, the body is said to be at rest if it is not changing its position with respect to time. If the body is changing its position with respect to time, then the body is said to be in motion. So when the body is said to be in motion, the body is said to be in motion if the body is changing its position with respect to the time. Suppose if the body is not changing its position at all with respect to time, then the body is said to be at rest. Got it? Now, suppose if the particle is changing from one point to another point, why the particle is moving, we are least bothered about that. We are not considering the cause for the motion. We are not considering the cause for the motion. Without considering the cause for the reason, without considering the reason for the motion of the particle, if you start describing the motion of the particle, then it is said to be a kinematics. So kinematics deals about the study of motion without considering its cause of the motion. So kinematics deals with the description of what? The motion without considering the cause of the motion, without considering the reason for the motion. That branch we call it as a kinematics. Suppose if you consider the cause, then it is considered as a dynamics. If you consider the cause for the motion, then we are going to consider as dynamics. So dynamics is the one where we are going to describe the motion of the particle by considering the cause. If you not consider the cause, then it is considered as what? The kinematics. Now, if the particle is changing its position from one point to another point, suppose if the particle is moving along a straight line, if the particle is moving along a straight line, if it is changing its position from one point to another point along a straight line, then it is considered as the motion in one dimension. So when the particle is said to be in one dimension motion, if the particle is moving along a straight line, if the particle is moving along a straight line, then we are going to say that it is motion in one dimension. That is our first chapter. That is what you considered as the motion in a straight line. So in the case of a motion in a straight line, we are describing the particle motion in one dimension. So we are going to talk about in one dimension. So one dimensional motion is considered as what? One dimensional motion is considered as what? Motion in a straight line. Now, if the particle is at the point A, if the particle is at the point A, this point usually we call it as a initial point. This is what we call initial point. Now, the particle is moving from A to B. The particle is moving from A to B. Then B is considered as a final point. So, what is B considered? B is the final point. What is A called? Initial point. Now, if the particle is moving, from A to B, let us say the particle has moved from A to B along a straight line, then this is considered as a motion in one dimension, which you consider as the motion in a straight line. Now, the particle may move from A to B like this, or it can move in the another path like this. It can take any path. So A is considered as this initial point, B is considered as the final point. It can move in any path. So whenever the particle is moving from A to B, it creates its own path. So it can move along the straight line. This is the first path. This is the second path. This is the third path. So whenever the particle is moving, either in the path 1 or path 2 or the path 3, it has to cover a certain path. It has to cover the certain path. So the path traced by the particle when it is moving from initial point to the final point, the path traced is what we called as the distance. So what is distance? Distance is the path traced by the particle from initial point to the final point. So this is the distance 1. This path is also the second distance. This is the third distance. So this path length, the length of this path is what we called as the distance. So the distance is also considered as the path length. So what is the path length? Path length is the distance covered by the particle from initial point to final point. Now, among these three paths, can you tell me which path length is more? Which path length is more? So the path length of 3 is more compared to the path length of the second one, and that is more than the path length of the one. So the path length of the third case is more than the second one, than the first one. So clearly you can tell among these three paths, the first path length is the less. The first path length is very less. This minimum distance whatever the minimum path we have there, this minimum path, the minimum distance is what we considered as the displacement. Displacement. So what is the displacement? Displacement is the shortest path. I hope students, you got the difference between the distance and the displacement. So what is distance? What is distance? If I consider the particle here, this is the point A. If the particle moves to the point B in different paths, it can move like this. Now, this is what we considered as the distance. This is the distance. The first path, this is the second path. The first path is also called the distance. But among these two paths, this is the minimum distance. This is the minimum distance. What is this minimum distance called? This minimum distance is called the displacement. So what is displacement? Displacement is the minimum distance covered by the particle from initial point to the final point. Yeah. Now, can you tell me the differences between the distance and the displacement? This is distance. Then you have to talk about the displacement. Yeah. So what is distance? Distance is the path length. So the length of the path traced by the particle from initial point to final point. So this is also called the path length. This is also called the path length. Both are distance. So the path length traced by the particle from initial point to final point is called as the distance. Got it? Yeah. Among this path length, the shortest excuse me, the shortest path length, the shortest distance, or the shortest path length, the shortest path length is called the displacement. And please remember, distance is always a positive number. It is always a positive. Distance can't take the negative values. Distance can't be zero. So please remember, distance is always positive value. But displacement may be positive, it may be negative, or it may be zero. So displacement may be positive, it may be negative, or it also may be zero. For example, if the particle is starting from A, it has covered a certain distance, let us say 2 meters to the point B, and it comes back to the same point. It has moved and it has come back to the same point. So if the initial point and final point are coinciding, there will be no shortest path distance. So the shortest path length will be 0. So in that case, the displacement will be 0, but the distance is 4 meters. So if the particle moves from A to B, then it comes from B to A. Then can you tell me what is distance? Distance is 2 plus 2. 2 plus 2, that is equal to what? 4 meters. But what about the displacement, my dear? Displacement is 0. Why 0? Because the initial point and the final point are coinciding. Between the initial and the final point, there is no minimum path length. So the displacement will be 0. So please remember, the distance is always positive, but the displacement may be positive, may be negative, or it may be 0. And also please remember, distance is not having any direction, hence this is considered as a scalar quantity. The distance is considered as what? A scalar quantity. But the displacement is having the direction. We must know the direction in which the particle is moving. So it has both magnitude and the direction. Hence, that is considered as the velocity. So velocity is considered as an example for the vector quantity, or you can tell indirectly, you can tell vector quantity. Instead of giving an example, you can tell it is a vector quantity. So displacement is a vector quantity which has the direction. Distance is always going to be a scalar quantity which is having only the magnitude, no direction. And one more thing, the distance is going to be measured in terms of meter. Even the displacement is also going to be measured in meter. Both the distance and displacement, is going to be measured in meter. Yeah. Now, students, what is the conclusion after analyzing this distance and displacement? You have analyzed the distance and displacement, isn't it? Now, what is the conclusions you can write from this concept? The first conclusion, you can tell the distance is always more than or equal to displacement. Distance is always more than or equal to displacement. Please remember this. Distance may be equal to the displacement, or maybe it will be more than that, but the distance can't be less than the displacement. Got it? Yeah. Or from this, I can also tell the distance divided by the displacement. The ratio I'm talking. The ratio of the distance to the displacement is more than or equal to 1. The distance by displacement, I'm talking the magnitude of the displacement, is always more than or equal to 1. So students, in order to analyze this distance and the displacement, we have considered a particle which is moving from A to B, isn't it? Now, to describe how this particle is moving, from one point to another point, we must have one set of coordinates. We must have one set of coordinates to describe this distance or displacement. That set of coordinates, the set of coordinates is what we consider as the frame of reference. So what is frame of reference? It is the set of coordinates which is prescribed, which is going to be prescribed in order to describe the motion of the object. To describe the motion of the particle, we are going to consider a set of coordinates to describe the motion of the particle. That is what we consider as the frame of reference. Usually, in undergoing the discussion of this motion of a straight line, we will usually fix the frame of reference as the earth. So earth is considered as the fixed frame here. With respect to earth, we are going to discuss the distance covered by the particle, distance covered by the body, displacement covered by the particle, and all those things. To describe this motion of the particle, whatever the set of coordinates you have fixed here, that coordinates we call it as the frame of reference. Suppose if the particle is moving along a straight line like this. Now, the particle which is moving along a straight line like this, we can fix up one coordinate axis like an x-axis. This is called the coordinate axis. Or similarly, you can describe the y-axis. Similarly, you can describe the z-axis. So any set of coordinate axis you are going to describe the motion of this particle is what we call as the frame of reference. I hope you got the frame of reference concept, students. Frame of reference means it is just a coordinate system. It is just a set of coordinate axis. Why coordinate axis? To describe the motion of the particle. To describe the motion of the particle. That is what we considered as the frame of reference. Got it? Yeah. Now, suppose if any frame of reference is at rest or moving with a constant velocity, then we considered as an inertial frame of reference. So what is inertial frame of reference? Inertial frame of reference is the one where the set of coordinates will be at rest, or that coordinates will move with a constant velocity. Remember that. That is what we called as the inertial frame of reference. This is not required. So inertial and non-inertial frame of reference. Inertial frame is the one which is moving with a constant velocity or at rest. Then what is non-inertial frame of reference? In the non-inertial frame of reference, the frame will not move with a constant velocity. There will be an acceleration. There will be an acceleration. If any frame is moving with certain acceleration, then it is considered as a non-inertial frame. Non-inertial frame. So what is non-inertial frame of reference? Non-inertial frame of reference is the one where the coordinates will not move with a constant velocity. There will be an acceleration. If the acceleration is not there, then we can consider as the inertial frame of reference. I hope students, you got the concept of the distance, displacement, and the frame of reference. Yeah. For the better understanding of the concept of the distance and the displacement, just I will give certain examples for you. You have to start giving the answers for this. Now, let us consider the first concept. Now, there is a particle here A. This particle A is moving in a semicircle to the point B with radius R. So the particle is moving from A to B. Now, can you calculate what is the distance covered? What is the distance covered by the particle from A to B? What is the definition of the distance? Distance is the path length. So this is the path length, right? That is nothing but half of the circumference. Half of the circumference. So half of the circumference is nothing but 2 pi r, which is nothing but pi r. So what is the distance of this semicircle? Pi r. Now you can tell what is displacement? Yeah. Can you tell me what is displacement? Displacement is the shortest distance, right? From where to where? From initial to final. So this is the shortest one. This is called the displacement. That is nothing but 2r. 2r. Because this is also r, this is also r. So the total distance traveled from A to B, the shortest one is called the displacement, that is 2r. So displacement will be 2r. The distance is pi r. Yeah. Let me try with another color. No, I think white is only a better. Yeah. Let us take the second one. Now the particle is at A. It has moved only 1/4 of the circumference. This is radius r, this is radius r, this is B. Let us say this is O. Now, what is the distance for this? Can you tell me what is the distance covered by this particle now? Now the particle has moved from where to where? A to B. The particle has moved from A to B. Can you calculate what is the distance covered? What is the distance covered? How much? It is 1/4 of the circumference, right? 1/4 of the circumference, right? So 1/4 of the 2 pi r. That is pi r by 2. So this is the distance covered. What about the displacement, Tapa? What about the displacement? The displacement is the shortest distance, right? So this solid line with an arrow mark is called the displacement. This is called displacement. This is called the distance. So distance is equal to 1/4 of the circumference, that is pi r by 2. How to calculate the displacement up here? The displacement is the shortest one, right? This is the solid line. By using the Pythagoras theorem, we can get the displacement, right? So using the Pythagoras theorem, the displacement will be root of r squared plus r squared. That is nothing but root 2 times of r. So what is the displacement? Displacement will be root 2 times of r. Now, let us take the third example. Students, you must imagine, you must get the concept. You have to bring the picturization in front of your eyes. Now, I'll give the third example like this. Let us say there is a road here. On the road, there is a wheel. The radius of the wheel is r. A. Opposite end of the A is B. Now, the wheel is rotating forward. The wheel is rotating forward. After forward, it will make off a revolution. It will make off a revolution. After off a revolution means, this A will come up, right? This B will come down. So the B will come in contact with the surface of the earth. The A will go up. The A will go up. So it has taken only off a revolution. Please be careful. Look at the condition. A wheel is moving forward on the surface of a road or on a horizontal surface. It is going to make off a revolution. Excuse me. It is making off a revolution. After making off a revolution, the point A will come up. The point B will come into contact with the ground because it is taking off a revolution. So this is called the displacement, right? This is the final point. This is the initial point. This is called the displacement. Let x be the displacement. Can you find what is that x? Can you find what is that x, students? Where x is the displacement of the particle. How to find the x? Look at the diagram. This is the diameter, right? So this can be taken as 2r, isn't it? Now, when the wheel has make off a revolution means half of the circumference has moved on the surface, right? What is half of the circumference? Pi r. Half of the circumference is pi r. This is 2r. This is 2r. Now, by using Pythagoras theorem, can't you get the value of x? You got it right. How you got this pi r? Because when the wheel rotates forward, whatever the half a revolution it is going to make, that half revolution should be on the surface. So half of the revolution is pi r, half of the circumference. So how to get the value of x? Yeah, using Pythagoras theorem, you can write x squared is equal to 2r whole squared, that is 4r squared, plus pi into r whole squared, that is pi squared r squared. So x value is equal to root of 4r squared plus, hello, so x is equal to root of 4r squared plus pi squared r squared. So this is the displacement of the particle. So x is equal to root of 4r squared plus pi squared r squared. I hope you got the concept related to how the distance and displacement is going to be calculated. I've taken one simple one, then I made the complicated in the third example. Yeah. For example, let us take another simple example, fourth one. Suppose if the particle is making 2 revolutions. The particle is making 2 revolutions. The particle is making 2 revolutions with radius r, let us say. If the particle is making 2 revolutions with radius r, can you tell me the distance and the displacement? Can you tell me the distance and displacement, students? If the particle is covering 2 revolutions, if the particle is covering 2 revolutions, what is the distance covered? The distance covered is 2 revolution, right? 2 revolution means 2 pi r plus 2 pi r, so 4 pi r. 4 pi r is the distance covered by the particle after making the 2 revolutions. What about the displacement? Displacement must be 0, right? Because the particle has moved from this end to this end, 2 revolution. But after completing the 2 revolution, the initial point and the final point are coinciding. If the initial point and the final point are coinciding, then there will be no shortest path. So the displacement must be 0. So the displacement must be 0 if the particle covers the 2 revolution. I hope you got the examples of the distance and displacement, isn't it, students? Yeah. Now you will have the definition here. You can see the definition. Here, I'm not given the definition directly for you. I've given so many examples now, and also you know in a position to tell what is distance and displacement right now. Yeah. Look at this slide. Look at this slide. You can tell what is the distance traveled definition now. It is the length of the actual path, isn't it? The length of the actual path. That is called the distance. Now, the shortest one is what we call, the shortest path length is called what? The displacement. And what is the major difference? Distance is scalar quantity, but displacement is a vector quantity. And you know that both distance and displacement are going to be measured in meter. Correct, no? Yeah. Now, I will give one example for you to think. Okay. Now, there is a particle A here. Now, it has moved like this for a distance of 10 meter. Then it has retraced and it has come to the point B. This is 3 meter. For this, I want what is the distance and the displacement. Distance and the displacement. Yeah. Now, the second thinking. Now, this is A. It has moved like this to the point B, where it is of 10 meter. Then it has moved to the point C, which is 10 meter. Can you tell what is the distance and the displacement? Distance and the displacement. Now, in the first case, distance is how much, my dear? Distance is the length, right? Here it has covered 10 meter plus 3 meter. So that is 13 meter. Here the distance is 10 plus 10. That is 20 meter. So the total distance is 10 meter plus 10 meter, 20 meter. This is 10 meter and this is 3 meter, 13 meter. What about the displacement? The shortest path. This is the shortest path, right? From initial point to final point. That is 10 minus 3, 7. So 10 minus 3, that is 7 meter is the displacement. What is the displacement here? The displacement is this shortest one. So according to your Pythagoras theorem, displacement will be 10 root 2 meter. Correct, no? This is root of 10 squared 100 plus 100. That is root 200, right? That is root 200. Root 200 is nothing but 10 root 2, no? So what is the displacement? 10 root 2 meter. Got it? So this is the differences between the distance and the displacement. Students, I hope you got the differences between the distance and displacement, and also I hope you are in a position to find the distance and displacement for the given conditions. Yeah. In the next class, let me have the concept on how to find the speed, how to find the velocity, and how to find the average of this speed and the velocity. Got it? And parallelly, I'm going with board concept as well as the competitive related formulas also I'm giving with some examples. So once if we complete with the theory concept, once if you start solving the MCQs for your NEET exams, for any competitive exams, we will use some shortcut methods, direct formula while solving the problems. But before going to those concepts, you must be very good in the concepts. So I'm giving so many examples so that you will be good in the concept to solve the MCQs. So I hope you have enjoyed the today's session, that is the differences between the distance and the displacement of the particle. So in the next class, I'm going to continue with the speed and the velocity. Thank you so much, students.